Hello class. This lecture today is on supply-demand equilibrium, or the basic foundation of neoclassical price theory. So, in order for markets to take place, we must have an exchange. And exchange takes place between a buyer and a seller. So we need both a buyer and a seller. And actually, both the buyer and the seller needs to have what the other one wants. We call this the double coincidence of wants. So the focus here is on the market for a particular good: cheese, chalk, chairs, widgets, whatever. So if we want to talk about markets, we need to talk about two components of markets: the law of supply and the law of demand. The law of supply states that there's a positive relationship between price and quantity supplied. So when the price of a product goes up, then the quantity supplied of the product goes up. If the price goes down, then the quantity supplied of that commodity goes down. Okay? So, similar with the law of supply, there's a law of demand. However, instead of a positive relationship, the law of demand states that there's an inverse relationship between price and quantity. So when price goes up, quantity demanded goes down, and if price goes down, then quantity demanded goes up. So we can have the law of supply and demand work without the theory of supply and demand. Now, the theory of supply and demand says that market prices are actually going to be determined by supply and demand forces. So the law can be in effect without the theory to be in effect. So recall, the law of supply simply states that as price goes up, quantity supply goes up. The law of demand states as price goes down, quantity demand goes down. However, we could have the law in effect without the without the theory of supply and demand being in effect. It will probably fall. So the law of demand is in effect, but how is the price determined here? The price was set by the Central Planning Board. Okay, so the law is in effect. However, the theory that prices are actually determined by supply and demand forces are not in effect, because here the price is just taken as given. Now we need to differentiate between many different types of demand. There's aggregate demand. Aggregate means total. So aggregate demand is total demand for all goods and services in an economy. However, we can break up this demand by focusing on just the demand for consumer products, which is aggregate consumer demand, or just the demand for capital goods, which is investment demand. So, and then there's more. Governments can buy products, and other countries can buy products from us, etc., etc. So we'll see how these come into play later. But a key concept in this course is this notion of aggregate demand or total demand, and we're going to talk about how aggregate demand drives economic growth. And then we need to differentiate between market demand and individual demand. So individual demand is one person's individual demand for a particular good or service. The summation of all individuals and their demands for goods and services constitute market demand. Market demand is the willingness and ability. These are the two concepts here. We need both willingness and we need ability to buy specific quantities of goods and services at alternative prices. Again, if we don't include ability, that's just wishing for something. Okay? It's not enough to be able to also afford an object. We also must be willing to purchase an object. For example, I wish I had a Lamborghini, but if I cannot afford a Lamborghini, then that's not demand. I can afford a set of Teenage Mutant Ninja Turtle pillowcases. However, I don't want them, so therefore I don't have the willingness to buy the product, and it's not demand. Further, when we talk about market demand, we need to hold constant our time period. Okay? Because as the time period changes, things can happen. Okay? It can change our willingness and ability to buy products in the future. So we usually talk about market demand as for a individual time period for normally 1 year. Further, we need to hold the ceteris paribus condition, or all else being equal, because willingness and ability can change depending upon many factors, and we want to focus on what happens to demand when price changes, and that's it. So we have to hold other things constant. If we fail to make the ceteris paribus condition, then when price changes and quantity demand changes, we're not sure if quantity demand has changed because price has changed, or has quantity demand changed because some other factor affected our willingness or ability to purchase an object. So, there's assumptions that we need to make that lie behind the market demand curve. In particular, what we're concentrating on is holding constant those factors which affect our willingness and ability to purchase a good. So, we need to hold income constant because income affects our ability to buy goods and services. We need to hold tastes and preferences constant because tastes and preferences affect our willingness to buy goods and services. And then we need to hold the price and availability of related goods constant because changing the price or availability of relating goods can affect our willingness or ability to buy specific goods. So there's two different types of related goods that we need to be concerned with. There's substitutes, and then there's complements. So an example of substitutes are coffee and tea. Okay, substitutes are two goods that are substitutes for each other. Okay, so we can either buy coffee or tea. Complements are two goods that go together. So we can buy coffee and cream, meaning that if there's no cream in the grocery store, then we're not buying coffee. So the price and availability of cream affects our willingness to purchase coffee. We need to also hold expectations of price, income, and taste constant. So, for example, if we expect our income to go up, that can change our willingness to purchase products today, or change our ability to purchase products today. We simply put it on the credit card, right? Or if we expect a life-changing event, like you expect to get a really good job 6 months from now, then you might have to purchase suits today. Or if you expect that you're going to have a baby in 9 months, well, then that's going to change the purchases you make today. So we need to hold expectations of price, income, and taste constant because changing expectations affects our willingness to purchase products today and affects our ability to purchase products today. We also need to hold the number of buyers in the market constant because we're talking about the market demand curve. Okay, so with holding constant number of buyers, if we increase the number of buyers, right, then the market demand curve will become greater, right? There'll be more demand if we increase the number of buyers. So we want to hold the number of buyers in the market constant. So like I stated earlier, individual demand is an individual's willingness and ability to purchase a good or service. So market demand is the total quantity of a good or service that people are willing and able to buy at alternative prices for a given time period, ceteris paribus. Or alternatively, it can be thought of as the summation of individual demands. Having made those assumptions, then, we can draw a hypothetical demand curve, which becomes a, like we said before, the law of demand is in effect because the curve is inversely related to the price. So, as price goes up, quantity demanded goes down, right? As price goes up, so if this is P1 and this is Q1, okay, then when price rises to P2, right, quantity demanded falls. Okay, so we can see that the law of demand here is in effect. Everything we said about market demand also applies to market supply in relationship to price and quantity supplied, and the factors that affect willingness and ability. So, market supply, similar to market demand, is the total quantities of goods that sellers are willing and able to sell at alternative prices for a given time period. Okay? We must also include both willingness and ability to sell products. Okay, it's not a statement of actual sales because this would depend on actual price. It's also for a given time period, and we also invoke the ceteris paribus condition. Now we need to make some assumptions behind the market supply curve. We need to hold the cost of production constant because changes to the cost of production can affect sellers' ability or willingness to put products out on the market. And the cost of production are subgrouped into two categories. There's input prices, and here input prices are equal to the prices of capital goods, prices of labor, and the price of natural resources. Okay, so we need to hold these prices constant. And then we need to hold technologically constant. In other words, what we're saying is we're saying no technological innovation. Further, we need to hold expectations of future prices constant. Since we're talking about market supply, we need to hold the number of sellers in the market constant. And when we do this, we can construct our market supply curve. Again here, the law of supply is in effect. Okay, let's look at this. if we're at this point, here's quantity supplied 1, here's P1, and then if price goes up to P2, here's quantity supplied 2, and what do we see? We see that increase in the price create an increase in quantity supplied, right? So the supply curve is a positive function of the price level. When price goes up, quantity supplied goes up, so the supply curve is increasing. Now we can put the market supply and market demand curves together, and here we see that the theory of supply and demand is in effect. And how do we know this? Because look, we have the law of supply, quantity supplied, with the increase in supply curve. The law of demand is denoted by the downward sloping demand curve. However, now prices, equilibrium prices, are determined by the interaction between the supply curve and the demand curve. Okay? This interaction, this intersection of supply and demand gives us our market price. So the theory of supply and demand is in effect with this cross. So the intersection of supply and demand creates where it intersects, I should say, is the equilibrium price, and that's the price where quantity supplied is equal to quantity demanded. And then it also depicts the equilibrium quantity, which is the corresponding quantity to equilibrium price. Now you can have disequilibrium then. So if the intersection of the supply curve and the demand curve gives us our equilibrium, then if the price were above the equilibrium price, quantity supplied would be greater than quantity demand. We would have an excess supply or surplus. So here's our example of market surplus. Now, if you can note here, we have price P1, which is above the equilibrium price because I can trace this out. Okay, this is our equilibrium price, and I should actually have there's our equilibrium quantity there, quantity star. Sorry, I should have had that there. So we have P star and quantity star, which gives us which it denotes our equilibrium price and an equilibrium quantity at the intersection of the supply curve and the demand curve. However, now when we have a price P1 above P star, then quantity demanded is this much, right? Where at this price it intersects the demand curve, and then at this price quantity supplied is this much. Okay? And now we have quantity supplied greater than quantity demanded, and we have quantity supplied is greater than the equilibrium quantity. So what is this equilibriating process? Well, when you have quantity supplied greater than quantity demanded, it simply means that there's excess inventories, right? There's more Coca-Cola on the shelf, right? Quantity supplied of Coca-Cola is greater than the demand for Coke. So what happens? Well, you have competition among buyers and sellers, which sets off this equilibrium process. Firms that have these excess inventories, what do? They cut prices. They put things on sale to try to sell their inventories. So as price falls, quantity demand rises and quantity supply falls until this process continues until you reach equilibrium, where the market price is equal to P star, the equilibrium price, and that's where quantity supply is equal to quantity demanded. Okay, so you have sellers doing everything they possibly can to lower the price, because here if price is up here above P1 or above P star, then quantity supplied is out here and the equilibrium quantity is here. So firms cut prices, and as they do so, they move along the supply curve until they have a price with just enough, where the amount that they're supplying is equal to the quantity that's being demanded by consumers, and you get equilibrium. Okay, now what if you have disequilibrium where you have the price below P star, and that's when quantity supplied is less than quantity demanded, or there's excess demand. So here is an example of excess demand. Again, we showed a mark where the equilibrium is here. Dotted lines. There we go. Okay, so right here at this intersection between quantity supply and quantity demand, you get the equilibrium price and get the equilibrium quantity. Now here, when the price P1 is below P star, we have quantity supplied. You just follow this price along until it intersects the supply curve. So quantity supplied is down here at QS2. Quantity demanded is up here at QD2. You have more being demanded than what's being supplied by businesses. So when consumers demand more than what's being supplied, that means that there's excess demand. Well, what happens? Well, when consumers demand a lot of goods and there's a limited quantity available, then consumers end up bidding up the price. And consumers will bid up the price and will move along the demand curve until the two are equal. So this equilibrium process, you have competition. You must have competition between and among buyers and sellers. Okay, it's not enough to have competition between buyers and sellers. You need to have competition among buyers as well, because it's the buyers which bid up the price and set off this equilibrium process. So as the price goes up, demand falls and supply rises. This process continues until the equilibrium price, until the price is equal to the equilibrium price and quantity supplied is equal to quantity demanded. So the role of competition in our economy, there's two aspects. You must have competition between buyers and sellers, and you need to have, otherwise, one side wants the price up, the other wants the price down, and a competitive process occurs to determine an agreement. And then you also must have competition among buyers and among sellers. Sellers compete with each other to gain market share and profits, and buyers try to outbid one another for goods they want to purchase. So competition forces buyers and sellers to do exactly opposite of what it seems they want. It forces sellers to cut prices, and it forces buyers to bid up prices. So this struggle between buyers and sellers is the competitive market mechanism that pushes and pulls the market back to an equilibrium once there has been a disequilibrium position. Now in the last slide we're talking about movements from a disequilibrium position to an equilibrium position, which in this first case is talking about movements along the supply curve or along the demand curve. This is distinct from moving from an old equilibrium to a new equilibrium, which consists of causing the curve to shift. Okay, so just like I said, we need to make a distinction between movements along the curve versus shifts in curves and changes in assumptions behind the curves. Okay, so the shifts of the curve cause because we change the assumptions. So a shift out of the demand curve means that the demand curve just is a parallel shift out, and then that then creates a new equilibrium position, P2, Q2. So P2, Q2 is a new equilibrium position, and P1, Q1 is the old equilibrium position. So shifts of the curve move from an old equilibrium position to a new equilibrium position. So what can cause the demand curve to shift out? Well, a handful of things. Recall our assumptions for the demand curve is it's drawn for a given level of income, given tastes and preferences, and given expectations. So the demand curve can shift out if any of these things change. If our income goes up, we demand, as consumers, we will demand more goods. So the demand curve will shift out if our income goes up. If our tastes and preferences change and we all of a sudden have a strong preference for certain goods or services, that's going to cause the market demand for those goods and services to shift out. If you increase the price of substitutes for a product, then we're going to stop buying those substitutes and we're going to start buying more of another good, which is going to cause the demand for that good to shift out. If you decrease the price of complements, right? Think back again to the coffee and cream example, right? If we decrease the price of cream, then it's now cheaper for us to buy the combination of both coffee and cream. So if you decrease the price of cream, that's going to increase the quantity demanded of cream, but since we always buy coffee and cream together, it's going to also increase the quantity demanded of coffee. Or changes in expectations of any of these can cause the curve to shift out. And then more buyers in the market. This is because the market demand curve is drawn for a specific number of buyers, so increasing those numbers of buyers shifts the demand curve out. So if increasing income, stronger tastes and preferences, more market demand, increasing the price of substitutes or decreasing the price of complements can cause the market demand curve to shift out, then the market demand curve can shift in from decreased income, right? A fall in your income, we demand less goods. Weaker tastes and preferences. Okay, we no longer have a preference for certain goods and services. So the demand curve shifts in. Decreased price of substitutes. We shift away from the goods we're buying to buying more substitutes. Increase in the price of complements. The price of cream goes up, so therefore we buy less cream, so demand for coffee falls. Or changes in expectations of any of these. And then lastly, fewer buyers in the market, right? If there's fewer buyers, then the market demand must fall. So a shift in the demand curve looks like this. Here is our old equilibrium. So P2, P1, P2, Q2 is our old equilibrium. And then the demand curve shifts in, shown by arrows pointing to the left. Demand curve shifts in, which causes the price to fall, and quantity demand falls. But notice that this, okay, so this demand curve no longer exists. Okay, so this is our new equilibrium position. Okay, so we're moving from one equilibrium position to a new equilibrium position by changing the assumptions behind our model. So if changes to the assumptions behind the demand curve cause the demand curve to shift, then we would expect that shifts in the supply curve would be caused by changes or relaxing some of the assumptions of the supply curve. So the supply curve can shift in from higher cost of production, meaning higher input prices, and higher input prices here means wages can go up, or the price of capital goods goes up, okay, or a technological decline. What we mean here is illegal or illegalizing technologies. Recall from our last slideshow that governments illegalize technologies all the time for environmental reasons or what have you. And then it could also be created by dimmer expectations or fewer sellers in the market. So now we're going to leave the demand curve stable, and the supply curve is going to shift in. Okay? Now, if we start initially, right, look where the arrows are pointing to the left. Okay? So this is our starting point right here, or at this intersection. So we start at P2, or start at Q2, P2. Okay? So this is our initial equilibrium, then the supply curve shifts in, and this is our new equilibrium. Decreased quantity, decreased price, but there's still both the equilibrium condition. So what can cause the supply curve to shift out? Well, if cost of production were lower, in other words, decreasing wages, okay, or decreasing the price of capital goods, or technological innovations, or just simply brighter expectations. And then, obviously, since it's a market supply curve, more sellers in the market can increase the total market supply. So when the supply curve shifts out, again, we're starting at this initial point right here, P1, Q1, and the supply curve shifts out for any of those reasons that we just mentioned, and then that causes then price to fall, quantity to rise, and then we move to this new equilibrium position. Now the law of demand usually holds. Again, the law of demand states that there's an inverse relationship between price and quantity demanded. However, it can be violated that when the price goes up, demand actually rises. And this is called a Giffen good. So an example of a Giffen good is in Ireland during the potato famine. Price of potatoes went up, the demand for potatoes also went up. Why would this happen? Well, because the average family ate potatoes for dinner 6 nights a week, and 1 night a week they ate meat. When the price of potatoes rose, your average household could no longer afford the meat, so instead of eating potatoes for 6 days, they ate potatoes for 7 days. So therefore, increase in the price of potatoes, increase the quantity demanded for potatoes. Also, the demand curve can be upward sloping when people view their price as an indicator of quality. So when the price of a good goes up, they think that this must be great, and then they demand more of that good. So in consumer theory, a number of interesting tendencies along these lines. You have the bandwagon effect. The bandwagon effect is you buy something to be part of a crowd. An example of this is maybe buying ripped jeans or whatever, right? You buy it because other people are wearing it, or Coach purses or whatever. Then you have the snob effect, okay? Something that can distinguish yourself from the crowd. It can be either designer jeans, right, or really ripped up jeans that are more ripped up than other people, but a lot of people wear ripped up jeans now. But you want to buy something to distinguish yourself from the crowd. Or you can have the Veblen effect after The Economist, which we read Thorstein Veblen. And the Veblen effect is this notion of conspicuous consumption, that you buy something to show that you can afford it. So the example I gave in class was, I believe, Harley Davidsons and yachts and whatever. Okay, but normally these are special cases, and the law of demand is said to hold in most cases, typically in neoclassical economics. So when price goes up, quantity demand goes down. When price goes down, quantity demand goes up. But now, how much does quantity demand change when price changes? This is our notion of elasticity. Okay? In economics, elasticity measures the sensitivity or responsiveness of one variable to another. Okay? So we typically equate elasticity using the midpoint rule. Okay, so the midpoint rule, if elasticity is defined by the percent change in quantity divided by the percent change in price, then in economics, this numerator becomes percent change in Q. We don't typically do Q2 minus Q1 divided by Q1. What we do is we do Q2 minus Q1 divided by Q2 plus Q1 over 2. Okay, that's our numerator. Okay, that's this right here. Okay, so to calculate percent change in quantity, we take Q2 minus Q1 divided by Q2 plus Q1 over 2. And then we take that divided by P2 minus P1 divided by P2 plus P1 over 2. Alright, that's our midpoint rule for elasticity. Again, elasticity measures the sensitivity or responsiveness of a change in one variable to a change in another. So here, we're measuring the sensitivity or responsiveness of a change in quantity demanded with a change in its price. So this is, when we talk about elasticity, what we typically think of here is own price elasticity of demand. It's a sensitivity or responsiveness of a change in demand for a good to a change in its own price. It's measured at percent change in quantity demanded of good X divided by a percent change in the price of good X. So What are the factors that determine own price elasticity demand? The availability and price of close substitutes. If there's many, it's going to be elastic. If there's few, it's going to be inelastic. The percent of a budget devoted to a good. If it's small, it's going to be inelastic. If it's large, it's going to be elastic. Time. In the short run, goods are inelastic. In the long run, goods are elastic. So, who cares about own price elasticity of demand? Well, firms care. If a good is elastic, right, this means that goods are, it means that quantity supplied is highly sensitive. If own price elasticity demand is elastic, it means that quantity demanded is highly sensitive to changes in the price. Okay, so when goods are elastic, when the price goes down, total revenue goes up. When goods are elastic, when price goes up, total revenue goes down. However, inelastic price, okay, if goods are inelastic, when price goes up, total revenue goes up. When price goes down, total revenue goes down. Inelastic demand simply means that quantity demanded is not very sensitive to changes in the price level. Okay, so when the price goes up, quantity demanded doesn't fall too much, so total revenue goes up. When price goes down, quantity demanded doesn't go up very much, so total revenue will go down. And then unitary elastic, price goes up or down, total revenue stays constant. So in absolute value terms, when we calculate price elasticity demand, which is equal to percent change in quantity demanded over percent change in price, okay, if this fraction is greater than 1, the good is elastic. If this fraction is less than 1, the good is inelastic. If it's equal to 1, it's unitary elastic. If it equals 0, it's perfectly inelastic. Equals infinity, it's perfectly elastic. So here's our inelastic demand curve. Okay, so the elasticity is less than 1. Now, look. If we started here at that price P1 and here at Q1, right? And then the price goes all the way up to P2. Well, quantity demanded only falls by a very little bit, right? Price goes up by a lot, quantity demanded falls by a little bit, and total revenue is equal to price times quantity. So, right, we have P2, Q2 in this example is greater than P1, Q1, right? So, again, we have P1, Q1, P2, Q2. The multiplication, or the product of P2, Q2 is greater than the product of P1, Q1, or P2, Q2 total revenue is greater than the total revenue of the first one. Okay, so firms like it when their product that they're selling has an inelastic demand, because that allows them to raise price by a lot, and then that increases their total revenue. So goods that are relatively inelastic are goods that don't have very many substitutes. For example, heart medicine or gasoline or things like that. When the price of gasoline goes up, quantity demanded for gasoline doesn't fall that much, and the total revenue for the gas station and the oil companies increases. So firms like it when they have an inelastic demand curve. This is an example of an elastic demand curve, okay, where if we lower the price by just a little bit, quantity demanded goes up by a lot. So in this case, when price falls, total revenue goes up. This is the case with the unitary elastic demand curve. When price goes up, quantity demanded goes down, but every point on this demand curve has an elasticity of 1, or price elasticity of 1. And total revenue stays constant at every point along this demand curve. This example of a perfectly inelastic demand curve. This one, elasticity is equal to 0, or price elasticity demand is equal to 0. And any changes in the price, quantity demanded doesn't change at all. So this is an example of this is when you have absolutely no substitutes for a product. A product is so specific that any change in the price, you demand the same amount. An example of this could be like medications, right? It doesn't matter what the price of your medication is, you are going to demand the same amount, and that's based upon your biological needs, right? This is an example of a perfectly elastic demand curve. This is going to come in useful in microeconomics. We're going to see straight line demand curves all the time, and in the case of perfect competition, this is going to become a familiar result. But for now, we don't need to concentrate on it just by knowing that price elasticity demand is equal to infinity. So a demand curve facing a perfectly competitive market where each firm is so small that there are so many firms and none of them can affect market price is a market economic assumption that all price takers then they result in straight line demand. And that's going to be a normal situation. So just like price elasticity demand, we can talk about income elasticity demand. Income elasticity demand is percent change in quantity demanded over percent change in income. Again, to solve this, we're going to have to use the midpoint rule, and let y equal income. So to solve this equation, we're going to have to do Q2 minus Q1 divided by Q2 plus Q1 over 2. I'm going to run out of space here. Let me go to a different slide. So that's going to be equal to Q2 minus Q1 divided by Q2 plus Q1 over 2 divided by. Now we're talking about income, right? So percent change in income is in our denominator. So if we let y equal income, then we need to do our new level of income minus our old level of income divided by our average income. Okay, or divided by y2 plus y1 over 2. Now, quick note on this midpoint rule. When calculating elasticity, we can't do this divided by this, divided by this, divided by this, divided by that, divided by that. Okay, that's incorrect. Here we need to take, it's this divided by this fraction, and then this subtraction divided by this fraction, okay? And then it's this top piece divided by that top piece. make sure you do these elasticity calculations in order. So, with income elasticity demand, for normal goods, income elasticity demand is positive, which means when our income goes up, demand goes up. Or if we think about the formula, right? Percent change in quantity demanded over percent change in income, right? So when the denominator rises or our income goes up, then quantity demanded should go up, so this fraction is positive, right? For inferior goods, then I'm going to do a different color here. For inferior goods, we have percent change in quantity demanded over percent change in income, right? So for inferior goods, when income goes up, we demand less of it. In other words, the fraction here goes down. So this is normal goods, this is inferior goods. An example of inferior goods could be ramen noodles, powdered milk, whatever. When our income goes up, we demand less ramen noodles and less powdered milk. Next, we have cross-price elasticity demand, which is the sensitivity or responsiveness of demand for a good X to a change in good Y. So this, using the midpoint rule, is percent change in quantity demanded of good X divided by percent change in price of good Y. This is going to be equal to Q2 good X minus Q1 good X divided by Q2 good X plus Q1 good X over 2 divided by P2 of good Y minus P1 of good Y divided by P2 of good Y plus P1 of good Y over 2. Okay? And this is equal to our formula for cross-price elasticity demand using the midpoint rule. So, right, we take the change in quantity here in the numerator of good X divided by, or the percent change in quantity of good X divided by the percent change in price of good Y. Okay, now let's look at cross-price elasticity of demand. For substitutes, it's positive because if you have percent change in quantity demanded divided by the percent change in price, and then you have here good X on the top, good Y on the bottom. So if the price of coffee, call that good Y, let's say that that goes up, right? So the price of coffee goes up. So the price of coffee goes up, you demand less coffee, right? And since the price of coffee goes up, you want less coffee. Now your demand for tea is going to go up, good X. So cross-price elasticity of demand here is positive if two goods are substitutes. Whereas in the case of complements, you have percent change in quantity demanded of good X divided by the percent change in price of good Y. Now, with complements, let's say the price of coffee goes up, right? But if the price of coffee goes up, your demand for coffee goes down. And if your demand for coffee goes down, your demand for cream, good X, goes down, and we have a negative in the numerator, positive in the denominator, this fraction is negative, so cross price elasticity of demand is negative for complements. And then we have own price elasticity of supply. Price elasticity of supply is the sensitivity or responsiveness for responsiveness of supply for good X to a change in its own price. So it's percent change in quantity supplied over percent change in price, or that's going to be equal to, using the midpoint rule, quantity supplied 2 of good X minus quantity supplied initially divided by QS2 plus QS1 over 2 divided by P2 minus P1 over P2 plus P1 over 2. Okay? So that's equal to that. We always need to remember that when solving these equations, we're going to be using the midpoint rule. Then we can talk about wage elasticity of labor demand, which is the sensitivity or responsiveness of demand for labor to a change in its wage rate. And again, that's just percent change in labor demanded over percent change in wage. So again, you can just use the midpoint rule here. This is just the quantity of labor. That's just the price of labor. So the midpoint rule is the same. You could have interest elasticity of investment. And this top here is just the percent change in investment, or the quantity demanded of the quantity demanded of capital goods divided by, well, the price of capital goods are interest rate, so it's percent change in interest rates, so we can talk about that as well. Then you can have the interest elasticity of the money supply. It's the change in the quantity supply of money over the percent change in interest rate. So, that's basically the idea of price elasticity of demand. One thing to note here is that if you draw a demand curve, price, quantity, and then we draw a demand curve a flat demand curve here, there's a point in the middle of the demand curve here, and this is our point where everything is unitary elastic. Points up here are elastic, and points down here are inelastic. In other words, whether a good is elastic or inelastic or unitary elastic depends upon where the supply and the demand curve cross. So if the supply curve, we'll call it S1, crosses some point above the middle point, then the good is going to be elastic. If the supply curve crosses at some point below the center, then that, right, and here's our equilibrium, then that good is going to be inelastic. If the supply curve crosses just in the middle, then that good is going to be unitary elastic. So, in other words, as you move down the demand curve, goods become more inelastic. Now, the point along the demand curve where goods and services become more elastic is the point where businesses maximize total revenue. If you take this demand curve that I just draw before, and then you superimpose the total revenue, this isn't going to be perfect, but the point in the center the point in the center, or the point where the supply curve crosses the demand curve, is also the point where total revenue is maximized. On the lower half of the demand curve here, total revenue goes down. On the upper half here, total revenue goes up. So as price goes down, total revenue goes up, goods are more elastic. As price here is where we maximize the point, then as price goes down, quantity demanded goes up, but here's with goods are inelastic on this lower portion. So, and when price goes down, and if the goods are inelastic, then total revenue falls. So the point where total revenue is maximized is the point where the supply and demand curve meet in the middle. Alright, and that's all I have for supply, demand, and elasticity.